Alright, in this video we're going to explore some of the practical algebra that you need to successfully use this calculus shortcut. And sometimes it's going to feel like it's not that much of a shortcut, but it's certainly a lot better than using first principles. So to recall what we learned, if a function can be represented as the product of two different functions, then the derivative is basically going to require that you find the original function times the derivative of the second function, add that to the derivative of the first function times the second function. So in this case, we recognize the first function f of x. We can define that as the square root of x, or x to the 1/2 power. The g of x is the other part, the x minus x squared to the third. So that's two functions multiplied together. Therefore, we're going to use this format to find the derivative without having to use first principles. So it is a shortcut. The derivative then is, and I'm going to set this up carefully, so you can see with the color what I did. We're going to start with the first function times the derivative of the second function. So yeah, I didn't take the derivative yet, I just set it up. I'm going to add that to the second function times the derivative of the first function. Once again, I didn't take the derivative yet. That's what this notation is reminding me to do. So now that it's all laid out, I keep the x to the 1/2 power, and then I take the derivative of the inside function. But notice what I had to do here. I had to apply the chain rule. So I take the derivative of the outside, that's 3 times x minus x cubed to the second power, so I drop the power by 1. But then I have to take the derivative of the guts of the inside. So that I'll do later. As I finish this derivative, I keep the blue stuff, and then I just take the derivative of x to the 1/2. Remember, we're going to drop the power by, or multiply by the power. That's 1/2 times 1, and then drop 1/2 by 1, so now it's down to negative 1/2. So I need to finish up by taking this derivative, which would be 1 minus 2x. So there's the derivative of the inside. So I use the chain rule within the product rule. Add to that the 1/2 over here times the guts here, or that's the second function, and then your derivative. No, the rest of this stuff, let me stop. This stuff right up to here, this is the derivative, and it's absolutely correct. But as you can see, there's a lot of symbolism there, and there must be a way to make this a little bit cleaner, a little bit easier to work with. Later on, we're going to take the derivative of a derivative, and if you had to differentiate this function as is, that would be a nightmare. So not something we really want to do. So right here, I'm going to be aware of the fact that we have x minus x squared. There's two of those factors in the first term. This is all the first term. And that x minus x squared, there's three of those factors over here. So I'm going to take out two of the factors. This is like division. So if we take this first term and we divide by x minus x squared squared, we're left with 3x to the 1/2 power times 1 minus 2x. So this is brought down, and all this stuff here is brought down because I factored this out of the equation. Here, there's three factors. I only took out two, so I'm going to keep one of those three factors inside, plus the 1/2 I keep, and then I'm also going to keep the x to the negative 1/2 power. Now that's enables us to do some cleanup work here. We can multiply these together, and we can multiply these together, so we get an expression that looks up here a little bit nicer. So now I see that there's two terms that have 1/2 power, so I can collect those like terms. Two terms have a 3/2 power, so I'll collect those like terms. And here again, this is all mathematical cosmetics. I'm just using factoring and other approaches to make this easier to look at and easier to work with. So recognizing the 1/2 power is sometimes something that's annoying. We can actually factor out x to the 1/2 because that will be a factor of both of these. I'll demonstrate. Take out x to the 1/2 power, and you'll be left with, well, we divide x to the 1/2 by x to the 1/2, and we get 1, so it's just 3.5. And here, we have x to the 3/2 divided by x to the 1/2 gives us x to the 1 because we subtract the exponents. So all I have to do now is take the square root of this, because that's what x to the 1/2 is square root of x. This stuff is brought down, and this stuff was originally factored out. So this is a factored form of the derivative, and this is a much easier expression to work with. So Also, don't forget to check with technology. Desmos or the TI will give you the graph of a derivative function, but not the equation. If you enter in your equation in any form, it should match the Desmos or TI derivative. So make sure you look at that, because after doing all this work, you'd like to know that you did it correctly. One last example, and I'll go through this one really quickly. We take the first function times the second function. We'll do first times the derivative of the second. Then we'll do the derivative of the first times the second, which, we take the derivative of this, we have to remember the chain rule again. So we're going to take the half, drop the power by 1, and then take the derivative of the inside function. Then we have to add everything on this side, which is the derivative of x to the fourth, nice easy power rule, times the second function. The rest of this, now this is the derivative, and it is correct. I have to finish this part first. Taking the derivative of x squared plus 3, that's just 2x, so that's right here. Carry everything else down. And now all I have to do is cosmetics. The first thing I recognize is what's common in each of these terms. So I see that there's an x to the fourth and there's an x cubed, so there's 3 x factors that are in common, so I'm going to factor those out. And then there's a rule that if you find the lowest power, that's going to be the thing you want to factor out. Negative 1/2 is smaller than 1/2, so I'm going to divide everything by x squared plus 3 to the negative 1/2. So in the first case, that just leaves me with the 1/2, one of the 3 x's, and the 2x. Then we have the plus. We took out x cubed, and we have x squared plus 3 to the 1 power. Now, to understand what I just did here, I divided this by this to produce that. Here's what happens when you divide. You can look up here. We see that if you take x squared plus 3 to the 1/2 divided by x squared plus 3 to the negative 1/2, rule says we subtract the exponents, and when you subtract the exponents, you get 1 power. So that's how I got the 1 power right here. The rest, just clean it all up. So the first thing is, we could take the negative 1/2 power and make it a square root in the denominator. The negative brings it to the denominator. The 1/2 is a square root. Then in here, I'm going to distribute the 4. I'm also going to say a half times x times 2x is equal to x squared. Half times 2 is 1. X times x is x squared. Distribute the 4 and collect like terms. Once again, as a reminder, if you have the derivative, if you take it up to this far right here, you have the derivative. So that'll get you like a B+. If you can show off the algebra skills, that'll take you down to a more simplified level. That'll get you the A. So that's all I got for you. Hope this is informative. Have a good day.